Hello everybody, I'm Andy Phillips and this is Iron Concepts number 65. So last week I talked about the loss of the skill in our community when it comes to the utility of forge welding as a method by which to assemble ironwork. And basically I pointed out how this is an art I think we're going to lose over time because the basic tools that most blacksmiths have now, the methods of assembly are much faster and much better. This is just one of those tools that doesn't make money. And in that, you got to be careful not to get me wrong. I'm not saying that nobody will ever forge weld again. I'm just saying that we're going to lose some of the skills that we had. You won't have many people, if any at all, in the community like you used to who used forge welding as a point of assembly every single day as part of their trade. And you also got to keep in mind, too, that I'm not talking about pattern welding. I'm not talking about Damascus, and I'm not talking about artistic texturing. I'm talking about really using forge welding to put pieces together. All that aside, I got a lot of comments on last week's video, and I got a couple of emails on it. And I was really sort of surprised at the amount of people that were really interested in this and had a different opinion. And while my opinion has not changed, I did think that it would be worthwhile to spend just a little bit more time on the topic. So today, I don't want to debate whether or not the process itself will survive, because blacksmiths are hoarders, both of tools and of knowledge, and I know the process will survive. Whether or not anybody will be proficient at it is questionable, but I know it'll survive. Rather, today I would like to talk about what I know about the process itself, some of the things that I've seen, and some of the best ways, some of the best practices, and some of the best ways that I think you could learn those practices if this is something you're truly interested in. So there are three aspects of forge welding that I think are the biggest factors when it comes to making a good weld. And out of all the people that I've come across that forge weld and are good at it, I haven't come across anybody that disagrees that this is the main tenet, that cleanliness is king. You have to start out with clean metal, and you have to figure out a good way to keep it that way as you heat it up and get ready to stick it together. You see, you can clean the steel with an acidic flux, or you can file and wire brush it before you start forging or after you've started heating it. But every bit of dirt and debris and scale is going to work its way into your weld. It's going to make a barrier in between the two pieces of metal that you want to make into one. So you have to get the metal clean before you can start welding. But once you get it clean, even if it's halfway through the heat, keeping it clean is a totally different story. Moving it from the fire to the anvil even can be the very thing that contaminates it. Clean, hot iron wants to react with oxygen badly, and keeping the two apart is not easy. Chances are you're going to get some scale no matter how hard you try, but the less scale that you have, the easier that weld is going to be to make. It's really a vicious cycle, because the more scale that you have, the more that you need a higher heat in order to get your weld to take. And the higher heat that you have, the more scale that you're going to get. Thus, it's harder to weld. Outside of some basic videos that I had seen and what I had read was possible in the lab, this was really first in person by a blacksmith made evident to me by a guy named Billy Phelps. He was making good solid welds at an incredibly low heat by keeping his joints super clean and having those joints set up absolutely perfectly in a very oxygen-starved coal fire. On a side note, if you ever get the opportunity to work with Billy Phelps, especially get to work around him while he's welding, or anything for that matter, jump at that opportunity. It's not that he's some great teacher or some great scholar. I mean, he is sort of in his own way. But the reason that he can do all of the things that he does is because for him, if he needed to join two pieces of metal together, he had the choice between a stick welder, rivets, or welding. And those were the only options that he had, and he got good at what he had. He's a master in his own right, but it's because of the restraints of the available technologies that he had that he got good at these particular things, and to watch him weld is truly amazing. One thing, though, that Billy would have never done, one thing that Billy Phelps would have never done, was use the torch for welding because of the expense of it. But when I grew up doing my apprenticeship, we spent a lot of time making these quick production welds, and we used the torch to make those welds, because you could keep the torch at a very rich setting and keep the flame on it, keep the metal itself shielded up until the very last moment where you would pull the flame away and strike the two pieces together. And it made it so easy to make an incredibly consistent weld and be able to see what you were doing, as well to be able to get those pieces up to the correct temperature at the right time. But past the battle for never-ending cleanliness when welding, I would say that the next thing up would be the understanding of the materials themselves. Tool steel, stainless, nickel steel, pure iron all weld completely differently, and that's before you start mixing them all together or adding in other materials as you're welding too. Understanding all the materials that are going to go into that weld is as complex and as difficult as the process is itself. Just with fluxes alone, there's so many different flux recipes out there that have lots of really odd stuff, and that stuff is there for a reason. It's very common to flux with borax, right? It's one of the very first ones that comes to mind, and it's acidic, which actually helps it to break down the scale and debris that's there while it creates this sort of glassy envelope around the piece that's actually being welded. It works well, but it shouldn't be the only tool in your toolbox. If you're starting out with unclean material, it's wonderful, but the joint has to be designed in such a way that the flux can get out, because borax is very heavy and sticky. Sand and very fine granite dust will form a glassy envelope in the same way around a piece of steel. While they don't clean the surface, if your surface is already clean to start with, they actually evacuate the weld a lot easier. You can add copper, iron filings, carbon, nickel, and so on to your flux, and they all have a different effect on the way that your weld forms. And that's my point in a lot of that too. I'm no expert. I'm not even really that good at forge welding, but one thing I do accept and I do understand, and I think I perceive pretty well, is that it's a complex process. There's no one perfect method. There's no one perfect flux out there that welds absolutely everything. Just like a stick welder who welds for a living wouldn't use only 70-18 all the time. You shouldn't only have one tool in your toolbox. Speaking of which, the flux off of 70-18 apparently makes really good welding flux too. Alright, moving on. Last but not least is joint design, the actual physical design of the weld joint itself. We've all seen scarfed welds and joints that were upset in order to prevent those little thin spots that occur in the middle of a bar when you've welded two pieces together. The truth of the matter is, joint design is a very difficult concept, and it requires planning. This is where the puzzle pieces come together, quite literally, sometimes. I took a class a few years ago with a guy named Brian Brazil, and if you want to learn anything about welding, or rather, anything about blacksmithing at all in general, you should take a class from this guy. He is the type of person who can't help but to grep until he ends up with a complete working model of how a process should be. I had spent a couple of days or a few days with Brian working on tool making, and my mind was already kind of completely full by this point, but we just casually stumbled onto the conversation of talking about forge welding. And what he told me was one of those things that it took a while for it to sink in. It was so simple, and it was such a fantastic rule, but in a lot of my own welds, the way that they had failed, right, was due to just overlooking this one really simple thing. And that's that welding is hard enough to control as it is. When you design the joint where there's going to be a weld, it needs to have a definite start and a definite end. And that's where so many people fail, even with a simple scarfed weld, right, is that they don't look at in 3 dimensions where the weld is going to start and where it is going to stop, what that joint is going to look like all the way around. It sounds so blatantly obvious, it sounds so stupidly simple, but really, can you look over your last 100 forge welds that you've made, and can you actually point to where that weld was supposed to start and to where it was supposed to stop, all the way around? And chances are all the cold shuts that you have, all the delamination that you have, is part of that one flaw in joint design. And that's not even everything to do with joint design. The joint design of a weld is complicated, and it has to be thought through all the way to the finished bit of the forging, which is what, as smiths, we should be doing anyway, but we cheat a lot of times. Forge welding is a telling and unforgiving process. You can't hide your flaws. You can't hide from your lack of knowledge on the subject either. It either works or it doesn't. It's the type of process where you can't just pick one aspect of it and repeat it over and over again until you become proficient at it. You have to have a bird's eye view of the entire process. You have to be a good blacksmith in order to be able to start to master this type of process. And that's one of the things that makes it so difficult, is the amount of understanding and knowledge and experience that you have to be able to pull off this very simple process. So how do you learn this? How do you become truly proficient at forge welding? I don't think there's an easy answer. You can take all the classes that you want to. You can study with people who have worked a lifetime at it. You can practice it yourself every single day. And maybe that's a good start at it. It's a difficult process. It's possibly one of the most difficult processes to truly master in our trade because of how broad-reaching and how complex that it is. But there's the challenge. And if you accept it and you achieve it, your peers will completely respect you for it. But past that, few people will understand even how difficult of a thing it is that you do. And that's why I really don't think that a lot of people will endeavor down this road very far. So that's it for me this week. I hope you've enjoyed the drawing. If you have any comments, I'd love to hear them. And you're always welcome to send me ideas for new iron concepts to my email, which is in the description below. So until next week, thank you and goodbye.